Gostaria de chamar agora o senhor Harald Lotz, da VIZIMAX, para as palavras dele.
Ok. Boa tarde. Eu vou começar a minha apresentação em português e depois vou continuar em inglês. VIZIMAX é companhia canadense com uma matriz Montreal, Canadá. E VIZIMAX é uma formação de 3 companhias, STR, SNEMO e Presbiteriana. SNEMO é uma companhia de energia pura, STR, telecomunicações e Presbiteriana, IT. Nós trabalhamos juntos com Hydro-Quebec. Hydro-Quebec is the 2nd largest utility in North America. It is the 4th largest in the world. So, consequentemente, nós trabalhamos com IREC. IREC stands for Institut de Recherche de Hydro-Quebec. Nós temos mais 500 engenheiros que trabalhamos conosco. So, consequentemente, os produtos, a tecnologia da VIZIMAX é muito moderna para o Smart Grid. I just would like to mention something about Smart Grid. We are working around the world. We're working in Latin America, North America, India. We've just opened up an office in Moscow. I'm not so sure if this was the right decision. But anyway, many people are totally mesmerized by Smart Grid, by this word Smart Grid. And I would like to make a comparison to a different type of technology or an industry, what happened in the past. This is what happens today still in electrical networks. It is basically one directional. You've got the power generation. It goes down to the end user, to the customers. Now, if you look at Brazil, if you look at your banking system is one of the most modern, most sophisticated banking systems in the world, and always was. The first time I came to Brazil was in 1988. I was president of a Montreal company where we were working in software, banking software. Now, when you look at Brazilian banks, what do they have? They have smart networks. In other words, replace smart grid with smart networks. And what you have is you don't only have smart computers which drive smart networks, but also in the field you have very, very smart devices. Imagine your world today without automatic tellers. Automatic tellers are highly sophisticated computers, if you wish. Now, just look at your pockets. Most of you will have a smartphone. You will have an iPad. Now, what is happening is smart computing is all over, in all aspects, touches all aspects of your life. And now what happened, and this is just my personal opinion, this world has been overregulated during decades. Most of them, not only in Brazil, have been monopolies. And what you have is you have no incentive for competition. If you look at the computer world, you had the IBMs, the DECs, and what have you. Many of these companies have disappeared. So it was these companies who drove the competition. Now this has changed today. What drives in the computer world the competition? It is the consumer. Because we want to have better iPhones, we have better iPads, etc. And we are marveling today of what we have today in our pockets. Just imagine what is going to happen tomorrow. Now, this is happening today in this industry. All of a sudden, people say, well, enough. We have to be more productive. The networks have to be better. And also, this industry has to become much more competitive. I was in a meeting with VIZIMAX. This goes about 2 years ago. There were representatives of these companies here. There were people from the governments. There were people from the economies. And basically, what the result was that VIZIMAX showed how much more expensive electricity is in Brazil in comparison to what happens in the United States or in Europe. A guy who runs in Sao Paulo, churrascaria, he runs the same churrascaria in New York City, and here he spends about 20,000 reais a month on electricity, and in New York he spends about $2,000 a month, and consequently his steaks are much cheaper in the United States than it is here. So consequently, this is the smart grid has become a very, very urgent matter. It is not a solution from the cosmos or from outer space. It has existed, the technology exists, and what I will show you is basically what we have done is we have taken technology that already exists and has proven for decades, and we just transplanted this into the world of electricity. So consequently, we have solutions for wind farms, for power generation, for solar farms, etc. And I start with Syncrotech. Syncrotech, for people who are very technical, Syncrotech is a device that renders circuit breakers or reclosers intelligent. Basically, these are non-intelligent devices. And basically, what we do with this device, we control the moment when a circuit breaker switches at the right moment. It is agnostic. In other words, it works with all manufacturers like Schneider, like Alstom, etc. I go a little bit fast with this particular product. And what it does also, and this is of some interest, of course, it offers residual flux management. And what happens if you go to a person, to a manager in a utility, and you ask him how often does he actually perform maintenance on a transformer? In other words, how often has he opened up a transformer? And most of the time, if this gentleman is honest, he will tell you 20 years ago. And why do they open up transformers once every 20 years? Because when they open them and when they close them, you have influx network inrush, and that can, if this is not controlled, you have an explosion. So basically, what this product does, it controls the arc, which you see on that side. If you re-energize a transformer, uncontrolled, this arc goes up to 7.2 power units. And 7.2 power units, your transformer most likely would explode. With the Syncrotech, the arc is controlled, and we're talking about a power unit of 1 PU. Usually in Brazil, power units are 2.1. And this is, just to show you one, this is a Siemens installation. The reason why I show that to you, as I said earlier, they can work on Alstom, on CG, and Schneider, on any kind of circuit breaker. Here in Brazil, they are being sold by STD in Brasilia and by CG Global in Porto Alegre. This is a product which is of great interest because it mesmerizes many, many people. This instrument is a little bit larger than my hands, and it offers various functions in this one little box. And I will show you later on how it does it. It's an RTU, first of all. Basically it stands for remote terminal unit. And basically what it does, it offers a utility, predictive maintenance. Basically what that is if you look at Formula One racing, an engineer can tell Massa, if you continue driving like this, your engine will explode or your tires will overheat. And this will happen in round number 22, in a half an hour from now. The same principles, the same ideas we've taken in this product. Basically, we can tell a utility if you will have problems with your devices based on temperature, on liquidity levels, on voltage in, out, on vacuum pressure. In other words, you will know exactly when you will have a problem. And this is compared to preemptive maintenance, where you say every 6 months I open up this thing and I look in it and see if I have a problem. With this preemptive maintenance, you don't know what's happening inside your machine. predictive maintenance, you see exactly what is happening. This is just one aspect of this product. Then you have a data logger. You have a web server, and basically what it does, for the first time, can you actually remotely manage your devices, like circuit breakers or transformers, from your cell phone, from your iPad. Alarms, you can also see on your cell phone. And you have gateways and protocol converters. This I will show you a little bit later on. So this is this little thing. As I said, it's a little bit larger than my hand. We dealt with the Selgi, the two gentlemen which are here, not here anymore. And they looked and they said, Lotz, everybody in Brazil calls me Lotz. He said, this must be a very big machine. How do you install this up in a pole top? And well, it is not a very big unit. It's a little bit bigger than my hand. And what you have is it supports web HMI. It's got supports substation control language, which is based on XML, so it's very, very easy to use. But it supports all these little devices. Whatever happens in your grid, in your equipment, it can be shown on your pager, it can be shown on your smartphone, on your iPad, and it will adjust the information delivery automatically as to the type of screen you have. And yes, you can customize what you want to see, what kind of alarms you would like to have. This you can also customize. Of course, it supports SCADA, and it literally supports all the protocols. Like Brazil is a DNP3 country, 61850, we support 6870, and what have you. But not only that, we are converting legacy protocols, and we are converting legacy equipment or legacy IEDs, which are out there in the field, which are a great investment for utilities. We integrate them into the new modern infrastructure. This is just an example where you have a conversion of, you have Modbus, you have various devices, different devices, you have various protocols, and you have the right one sitting there in red, and it converts, it integrates, first of all, these relatively outdated devices, converts the protocols, and integrates them successfully into the central site, let it be DCS, or let it be SCADA, irregardless if it is fiber, if it is leased lines, if it is GPRS, Edge, or GSM. Another thing it does, and this is Hydro-Quebec, which developed that. In North America, and I'm sure also in Brazil, more and more you deal with IPPs, independent power producers. And these are companies who have their own power stations, etc., create energy and sell it back to utilities. But the utilities, they really want to make sure that these power producers follow certain standards. So they install a right one, and remotely from the central side of a utility will control and supervise and manage the circuit breakers and the transformers. Well, usually IPPs don't have transformers, but they have circuit breakers, and manage this. Now, if it really is a very small IPP, they don't need a circuit breaker, because the right one can take the role of a circuit breaker. This happens, of course, in regards to also with wind farms. Wind farms, well, becoming more and more popular here in Brazil. So this way you integrate, for example, you have fantastic wind farms in Fortaleza, which I visited recently. And what you have with this kind of product and approach, the utility actually manages this wind farm remotely and can see what goes on with this wind farm from a cell phone, from an iPad, and even if somebody is in church on Sunday morning and gets an alarm and he sees, well, I've got just a problem with this particular device. This is an interesting scenario. Recently, there was a congress here in Brazil for dealing with the solar the solar industry, solar installations. And we talked particularly with concentrated solar power plants. And we are participating in various projects. And what you see here, this is an installation in Seville, in Spain. And what you have 1,000, I want to be exactly, you have 1,488 mirrors. These are not solar panels. These are mirrors, which move every 10 seconds according to the sun and portray the rays of the sun to that heliostat, which you see there. Now, Brazil has a belt of very, very high solar activities, which goes from Teresina via, what is the other city? Palmas, Brasilia, Goiânia. There is a belt which you have an incredible concentration of solar power. Just to put things into context, the sun, with 45 minutes of sunlight, the energy produced by the sun can energize the entire world for 1 year. Of course, local companies here in Brazil, Telebrás, etc., are looking at this. Now, what does it take? Of course, everybody says that's very, very expensive to build. Yes, it's very expensive to build because you need cement, you need steel, you need glass, etc. And to implement something like this takes about 5 years. This is from the conception to the actually building, to the trials, etc. It costs millions. The lifespan of an installation like this is 25 to 30 years. So once it's built, it doesn't cost you very much. Now, the system that actually drives this, the system that actually manages all these mirrors, there's 1,488 of these mirrors. To move these mirrors every 10 seconds, because if they're not being moved every 10 seconds, there is not enough energy, enough power to move them ever again. But not only that, these have to be managed. There are software downloads. How do you upload or how do you to upgrade software on 1,488 mirrors? Keep in mind these mirrors are attached to PLCs, and here comes the secret. In 2 installations like this, the right one unit, which you've seen before, is being used. There are, and now listen to this, and this here comes now the data concentration, because the right one is also data concentrator. 120 right ones control 1,480 mirrors. Move them, manage them, collect the data, send the data up to a central control site, which then the control site will use to send on to a SCADA system. So people say, well, this right one really must be pretty good. I have to put a commercial in here. This right one has to be pretty good, because if we spend something like $55 million or $60 million in putting this thing up, whatever the intelligence drives this has to be solid. The German companies with whom we work on this Seville project, and we have another project in Las Vegas, well, in the Nevada desert, call this function the watchdog function. So this is another aspect of this little gizmo, this little product, which is called the right one. In terms of protocols, the PLCs are connected by RS-485, and then we use fiber optics and Ethernet, and everything goes over DN3 network. So this is the This is particular for this particular industry. Let me go just in terms of Brazil. Let me give you another example. Not only the energy sector wants to become smart, also the water companies here in Brazil. For example, we are having a project with Copasa, the water company in Minas Gerais. And what they do, they use the Right One product as a controlling device to control the pumping stations and remotely can see when their tanks are being emptied or when their tanks are being full. With DME, Electrica, they're using the Right One to run and control their substations and connect them to SCADA. Here you have FDIR. Everybody in Brazil talks about FDIR or self-healing. Now, again, I'm still talking about the same product. The Right One product offers several scenarios in this aspect. Why FDIR? We worked extensively with Salga on a project like this, and basically is not only here in Brazil, but all over the world. 80% of power failures, basically somebody picks up the telephone and calls the utility and says, I've got a problem. I've got 5 minutes, I got to rush. There are basically three approaches. There's a distributed approach to FDIR. And basically what it is, you have down here, you have the Right One product, and Right One controls each section in a grid. If one section goes down, the Right One automatically will redirect the traffic to a section where which is not affected, so it will only isolate this particular section where you have the problem. Now, in a decentralized way, you do not report back to SCADA. And this is our approach. You have SCADA, which is the central site, which controls the various sections of the grid through the Right One, and closes and opens whatever works and does not work. Now, even with centralized computer system, even if you have redundancy built in, what happens is the central site goes down. In this particular case, the Right Ones replace the SCADA system, monitor the peer-to-peer configurations, and once the site comes back up, reports this back. Now, one thing I forgot to mention, the Right One also shuts down and locks circuit breakers, shuts down sections of a grid. In other words, if you do have a problem, usually utilities have to send out a maintenance man and climb up a post and shut down a recloser. With the Right One, you do this automatically. This is a little box. The Right One you see in a little box. Now, many people say, how do you do this? Because this is such a miniature device. How do you do all these functions? How do you put all these semiconductors in this? How do you connect this? And basically, what we use, and we didn't invent it ourselves, I dare to say, we are using CAN bus. Anybody knows what CAN bus is? Anybody knows where CAN bus comes from? No, it doesn't come from the computer industry. It comes from the automobile industry. It was invented by Robert Bosch. And what you have, this is a modern car. Well, this slide is about 10 years old. I was VP at Motorola in semiconductors. And you've got these cars today, they're full of electronics. Now, in the car, you have a very limited space. How do you connect them? So Robert Bosch came up with the technology and invented car area networks. So we took this particular technology and we incorporated this technology into the Right One, and that explains why we can have so many functions in this little box. Our customers, 20 years ago, Semigi installed the first Syncotech. CMYKI is installing today about 15 or 20 of Syncotechs sold by CG Global. And we work around the world. Basically, that's the story. Thank you very much.